Here, today we'll start a new topic, that is properties of determinant. Here, that properties of determinant will start. So there are lots of properties. You can apply the property and in many cases of your determinant to find the determinant value. These are the very much usable method, and this is very important for your JEE also and board also. So if you have idea where the property will be applicable, then it will be very much easier for you to solve any kind of determinant. Now in the first property, what is given? The value of the determinant remains unchanged if its row and column are interchanged, right? The value of the determinant will remain unchanged if its row and columns are interchanged, right? So how it works? Here I have written one determinant A of 3 cross 3 order, whose value have already determined, that is 17, right? So interchange of any, interchange of any row and column is the same concept as like the transpose. As you know, the matrix transpose, if we interchange any row and any column, then its matrix format, it is known as the transpose of a matrix. So basically that property tell us that if we find any 3 cross 3 order determinant or any less than that, if we find any determinant value of a square matrix, then we'll get some value. After interchanging its row and column, that is after transpose of that square matrix, if we find out the determinant value of that transpose matrix, then the value will remain same. So if we take this example, A, here it is given. So basically we can write it as determinant of A will be equals to determinant of A transpose, right? So here determinant of A is written 2, -1, 3, 4, 1, 2, 1, -1, 5. Its determinant value is 17. So if we first write the transpose part, then it will be 2, 4, 1, -1, 1, -1, 3, 2, 5. Then if we find out the determinant value of that transpose, then it will also come, if we'll check, then it will also come 17. So that property holds, right? So this is very important property. And for interchange sign or notation is like that, right? Now, our next property is property 2, that is if any two rows or columns of a determinants are interchanged, then the sign of the determinant interchange also, right? If, what does it mean? That if you have any determinant, after solving, suppose the determinant value is coming 7, and after interchange of any row or any two column, then the determinant value will be same, but its sign will be interchanged. Previously the determinant value was 7, Now in this case, the determinant value, if we interchange, per interchange, the sign will be also interchanging, right? So, for example, the previous determinant value, if we take with the previous determinant value, here we can write A has the determinant value of 2, that was given 4, 1, 2, 1, minus 1, 5. This is the original determinant. Am I right? This is the original determinant. So its value is 17. Clear? So if we interchange, suppose I want to interchange this column with this column. So first you have to write C1 interchanging with C3. Then the new determinant structure will be like that. 3, 2, 5. Then that column 2 will remain same. And here 2, 4, 1. Right? So if we find out the determinant value, here also the value will be same as, better to write the determinant in the different name. So after interchanging, let the determinant name is B. So previously date A was 17. Now what will be the value of this determinant? Will be same, but its sign is minus 17. Now anyone again want to interchange row 1 with row 2 on this, not on A, on B, right? So let the new determinant name as C. So if we interchange row 1 and row 2, then it will be 2, 1, 4, because all the row 2 element will come to that row 1 places, occupy the row place of row 1, and all the elements of row 1 will come to row 2. So it will be 3, minus 1, 2. And the row 3, we have not done anything on row 3. So it will be same like previous. So it will be as it is. So here also previous value was minus 17. So one interchange per step is possible. In per step, you can also interchange 2 or 3 cases. Here I have interchanged row 1 and row 2. That is one operation has done. I'm applying one property. So based on the previous value, the determinant value will be also interchanged. So minus of minus 17, then it will be same like the first one, right? Now come to property 3, right? What is given? If any two rows or column, if any two rows or column of a determinants are identical, so we can write it as the identical property. All corresponding elements are same, then the value of the determinants are 0, right? So how it works? How it works? Suppose you have one determinant, let's say A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is one determinant is given A, 1, 2, 3, 4, 5, 6, 7, 8, 9. First you have to check whether any identical row or column is there. So first check row 1. Row 1 has any matching with row 2 or row 3. So row 1, row 2, row 3, all are different elements, right? All are different. So now check for the case of column 1, column 2, and column 3. Any such full column is same with another. Here, no such column is matching with any other column. So here you cannot apply the property 3. But here you can apply, let's say, 1, 2, 3, 4, 5, 6. Here also 1, 2, 3 is given. So first you have to read carefully what determinant is given. So here we'll write row 1 and row 3 are identical. Therefore, directly, without any solve, directly just put the value of that determinant. Let's say determinant value will be 0. This is property 3. Now, come to property 4. What is given? If each element of a row or column of a determinant is multiplied by a constant, then its value gets multiplied by k, right? First you have to know how scalar product works on determinant. It is not like matrix. For the case of matrix, we know that if we multiply any scalar element with any matrix, then that scalar element will be multiplied with each and every element contained in that matrix. But this is not applicable for the case of determinant. So here, suppose you have one determinant, I'm writing A, you have one determinant. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Let's say its value is k, right? So better to write its value is determinant of A, right? So if we multiply, this is determinant B, k into 1, 2k, 3k, any constant is there in row 1, and others are same like the previous one, 7, 8, 9, right? So previously its value was, first take common k from row 1, then you can write it as 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you know that this value is del A, so your value will come del of A. So in this way, you can write del B is equal to K into del A, right? So this is property 4. Now comes to property 5. Here this is given if some or all elements of a row or column of a determinant are expressed as sum of 2 or more terms, then determinant can be expressed as sum of 2 or more determinants, right? So let's check. Here A is one determinant given. Its element is A plus K, B plus K, and C plus K. Rest of the elements are D, E, F, G, H, I, right? How it works? This is nothing but the summation of these two determinants. First, you have to check whether that addition is same for all these three. If yes, then you can write as the sum of two different determinants. How? A, B, C, D, E, F, G, H, I plus of K, 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 D, A, F, G, H, I. So the rest of the elements will be same. This is when all these three are same. Suppose you have different constant K1, K2 and K3. In that case, what you will do? This A, B, C, D, E, F, G, H, I, that determinant will be remain same. Here, these values will be interchanging, right? Now, come to property 7, because property 6 are in the operation part of the determinant, right? So what is property 6? Sorry, 7. Here this is given if each element of a row or column of a determinant is 0, then its value you can write directly 0. No such calculation, no such expansion is required. Directly you can put the value of the determinant is 0. Very easy. How it works? For example, A is a determinant given A, B, C. Second row, all the elements are 0. And the third row is D, E, F. So its value you can write directly without solving. You can write it directly that the value is 0, right? So the determinant value is 0. Clear? Now property 8 is very important property. This is the diagonal property. We'll start. What is that? In a determinant, if all the elements on one side of the principal diagonal are 0, then the value of the determinant is equal to the product of all the elements in the principal of diagonal. What it is? Suppose you have one determinant. Suppose you have one diagonal matrix. Diagonal matrix means all the elements are in the diagonal, right? So A is a diagonal matrix, A11, and we know that for the case of diagonal matrix, all the remaining element will be 0, 0, 0, A, 3, 3, right? So whenever we'll try to find out the value of this determinant, det A, just the product of all the diagonals, A11 into A22 into A33, right? This is very important, and this is possible when the order is greater than equals to 2, right? So this is the diagonal property. If any diagonal matrix will be given, first identify the diagonal elements of that square matrix for 3 cross 3 order, or for 2 cross 2 order, and higher than that of 2 cross 2. So you can easily and directly you can apply that property. If the matrix is square matrix and you have to find out the determinant value, then take the determinant, the diagonal elements, and just product of it, you'll get the determinant value of that square matrix, right? This is very important. Now comes to property 9, which is not given in that material, but this is very much important for your JEE, right? This is very much important for your JEE section. Clear? What it is? Suppose you have one determinant A, that is, let's say A, B, or better to write, suppose you have one determinant A equals to A11, A12, A13, A21, A22, A23, A31, A32, A33, right? In the previous class, we know that how to find out the minors and cofactors of the determinant, right? So you can get easily the value of minor and cofactors, right? So for A11 here, for A11, you know that minor value will be M11 and cofactor value will be C11, right? So suppose let all the cofactor values we have already got. So for A11, cofactor value, let it is represented in the different color. Cofactor value of C11 is A11 is C11. Cofactor of A12 is C12. Cofactor of A13 is C13. In this way, we can say that you have already got all the cofactor values, right? Now what you have to do, you have to form one different determinant where the elements will be all the cofactor values, right? So we can say that this is our, let's form one cofactor matrix, and if we'll find out the determinant of that cofactor matrix, then what will be the relation with the given matrix, right? Check it. What is the formula? So if we find out the determinant value of that matrix A, then suppose it is denoted as determinant of A, right? After solving that A square matrix, you are getting the determinant value del A, right? So if you exchange the place element value, and if you form one more different matrix that is known as cofactor matrix, let is denoted by B, where all the elements are cofactor elements. Here the cofactor C11 is the cofactor of A11, C12 is the cofactor of A12, C13 is the cofactor of A13, same as C21, C22, C23, C31, C32, C33. Suppose this is also one determinant format. This is also, we can say that if we write it in the matrix form, this is known as cofactor matrix. Cofactor matrix. I have written here directly the determinant form. Here also that A matrix I have written the determinant form. So the determinant value of A square matrix 3 cross 3 order is del A. Here the cofactor matrix, first what you have to do, directly without solving you can get the direct value if you know the value of that the main square matrix. So first you have to identify what is the order of this cofactor matrix. That is, you have to find the value of n. Here you know that this is 3 cross 3 order, so value of n is 3. So what will be your determinant value? As you know, the value of the main matrix A is del A. So the determinant value of B will be directly using the formula del B equals to del A whole to the power n minus 1. This is very important formula. If we apply that formula, we don't need to calculate the value of that square matrix. We can get easily without expansion. If we know the value of this, then we can directly write del A whole to the power 3 minus 1, that is del A to the power 2. Or better, you can write it in this way. This is very much shortcut trick, and you can apply it. You can apply it in the JEE. The sums will be given like this. Suppose A1 determinant is given, its value will be given, for example, 7. Then you have to find out the cofactor of it. The question will come like this: find the cofactor and find the determinant of that cofactor matrix. So no need to calculate, as you know that the value of the given matrix A is given, determinant value of the given matrix A is 7. So your cofactor matrix is B. No need to find the cofactor values. Directly you can write. First identify what will be the order of your cofactor matrix. You know that for any cofactor matrix, the order will be same as the original matrix. So here the order of B is 3. So your answer will be directly, you can write 7 to the power 3 minus 1, that is 7 to the power 2. Answer will be 49. So this will be your correct answer. this is mainly important for JEE, right? Now comes to the evaluation part of the determinant. You have to know how you will apply the property in the different proof you have to apply, otherwise the main question will come from that property section. All the proofs which will be given, you have to apply the property. This is very much important. You have to know the evaluation technique, right? So the technique, first you have to know Ri is nothing but the ith row, as you know that, same as Ci ith row of ith column. Here previous section we have discussed, for any interchange of row or column, you will represent it. You have to write in each and every steps. Ri interchange with Rj, Ci interchange with Cj, in this way. And the major, very much important evaluation technique is Ri apply with the new row you'll get with this. That section is very much important. Same like that, you can apply it in the column section, right? How it works, I'm giving you one example. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So suppose how this works, if I want to exchange R1 with R3, in a particular step, you cannot interchange both row and column. This is very much important whenever you apply any property or any evaluation technique or any operation. You have to keep it in your mind that in a particular step, you cannot apply the both row and column operation. Either you have to apply the row operation or you have to apply the column operation, right? So here I'm interchanging row 1 with row 3. Then we know that whenever one interchange, one negative sign will come. Here I will write 7, 8, 9, 4, 5, 6, 1, 2, 3. As you know, here if we interchange in property 1 or property 2, supposing I hope in property 2, if we interchange, the sign of the determinants are also interchanged. So as we have interchanged R1 with R3, so the determinant sign I have written with the interchanging sign, right? Now if in that step you want to again interchange C2 with C3, then again one minus sign will come, minus, and the previous minus, sorry, minus, and the previous minus, it will be plus. So now exchange column 2 with column 3, so column 1 will remain same. Now column 3 will come in place of column 2, 9, 6, 3, here 8, 5, 4, 8, 5, 2, right? So ultimately it will be 7, 4, 1, 9, 6, 3, 8, 5, 2, right? Here I have explained that operation you can apply. Now this is the major operation on this, suppose you want to just erase it. Now check how row operation can be implemented, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I want a new row, row 1. The previous row 1, let's write it as R1 dash. You can also write, or you can write R1. So new row 1 you want to form with the help of the previous row 1 along with the summation of row 2, right? So what will be your determinant value? Sorry, the new determinant structure. It will be 4 plus 1, that addition part, 4 plus 1, 5, previous row 1, 1, here 2 plus 5, 7, 3 plus 6, 9, and the row 2 remains same, 7, 8, and 9, right? Suppose you want to apply one more column operation after this step. What operation? You have to write in every step. In every step, you have to write which operation you are applying. You have to write it, right? So in the first step, I have applied one row operation. After that, based on the new determinant format, I want to apply one column operation. How it works? What operation? C1 goes to C1 plus C2 plus C3, right? So your new column 1 will be the summation of the previous column 1 element with column 2 element with column 3 element. So the new column 1 will be 5 plus 7 plus 9. Here 4 plus 5 plus 6, 7 plus 8 plus 9. And the rest of the element will be same like the previous one, as because you have not done anything with this, right? So you have to calculate these values and your new determinant will be formed. In this way, you have to apply the operation part, and this is the main part of the determinant along with the property section. So if you read all this part carefully, you can easily solve the proof of any determinant. One more technique I will explain in the next section. Now, the main part after completion of the property and operation, anywhere for any proof will be given for determinant. After applying any property, after applying any operation in each and every state, your target, what will be your target? Your target, by any way, you have to write the determinant with this form: 1, 1, 1. For example, these are the elements A, B, C, D, EF, right? So that part is very much important. Now the question is, we can write it in only row 1? No. For any, after applying the properties, after applying all the operations, your target is first you have to write the determinant in 1, 1, 1 in any row or in any column. This is your first target, right? So here I have written 1, 1, 1 after solving few steps. Suppose the sum is given after applying the properties and operations. Our target, I have formed it in the first row 1, 1, 1. For examples, any other students or anyone, after applying the properties, after applying the operations, you may write it the third row or second row or first column, second column or third column, but your target will be 1, 1, 1 form. You have to write it, the determinant in 1, 1, 1 form, right? Then you have to write it 1, 0, 0, right? So these two areas is very important. First, convert it in 1, 1, 1. After that, you have to write 1, 0, 0 after applying the operation. Clear? So if you know this part, then you can easily find out all the determinant value, right? So please check all the assignments parts. I have already some sums I have already solved. You can check any examples from any book, and just if you go thoroughly with each and every examples, you can get you'll get the different ideas how determinant properties can be applied, right? Now we'll start the application part. What is the application part? Area of triangle, right? So if we draw one triangle, if we draw one triangle A, B and C. A as coordinate x1, y1, B x2, y2, C x3, y3, right? Area of triangle with the help of determinant, right? So I'm drawing one circle with coordinate of A x1, y1, B x2, y2, C x3, y3, right? This is A, this is B, this is C. Now, if you go, you have to follow any rotation. I'm choosing this rotation, right? This is anti-clockwise direction. As you know that area of any geometrical figure will be always positive, and you know that you can get any determinant value. It may be negative value, it may be 0, it may be any positive one. But here in that application part, the area of the triangle, as it is area, so your value should be positive or 0, right? And you have to keep it in your mind that as you are trying to find out the value of area of triangle, you have to mention the unit. So you know that, all of you know that area of any geometrical figure will be square unit, right? So unit will be square unit. What is the formula? Area of triangle ABC. First write one modulus, right? Why this modulus I have written? As area is positive. So we'll take the modulus value. Before that, first I'm writing how it works. Half into x1, y1, 1, x2, y2, 1, x3, y3, and 1, right? Now, if you'll solve it, then the value will be half into, how you will select? First write x1, then difference of the next two y part, y2 minus y3, but you have to keep it in your mind about the rotation. As I am following the anti-clockwise direction, so you have to follow the anti-clockwise direction. If you will follow the clockwise direction, then you have to follow the throughout to find the area throughout the clockwise direction. So here I am doing it with the help of anti-clockwise direction. So x1 minus difference of the next two y part plus x2, then select the next two y part, y3 and y1. So write y3 minus y1. Then x3, as you are selecting x3, so what will be the difference of next two y2 portion? y1 minus y2. So write the unit square unit, right? And one is the special case, that is the case of collinearity. As you know that if area of triangle ABC will be 0, then we can say that A, B, C are collinear, right? As the area portion will be vacant, there is no, when the area value is 0, the area portion will be vacant. So the figure will be look like this, right? So B, A, and C. This is in the same line. So ABC will be collinear, right? So you can follow any book. You can take the different examples. In that study material also, we have given different, we have solved few sums. You can follow this. After that, just start the assignment portion. You can follow any exercise from any of your book. And if you have any doubt, then please comment in that comment box. We'll try to solve it as our convenience. Thank you so much.